Good evening, everyone. This is Dawn. Thank you for joining this webinar brought to you by ASQ Innovation Division. The topic of tonight's webinar is Data Science and Quality Professional. Data science is the process of asking meaningful questions and getting answers from data. By that definition, quality professionals are and always have been data scientists. This presentation examines the breadth of skills and requirements for data scientists from the perspective of the quality professional. Based on observations from consulting in both quality and data science fields, 4 types of data scientists will be described in detail: the strategist, the boundary spanner, the applications ninja, and the communicator or storyteller. Quality professionals need not feel that they be proficient in all forms of data science. By understanding these areas, quality professionals can identify new opportunities for professional development that naturally leverage their strengths and career histories. The learning objectives are understand the nature of data science, understand the nature of big data, learn how to build a big data infrastructure in an organization, identify how advanced analytical tools can solve problems. Please note that this webinar is recorded and the recording will be available on ASQ Innovation Division YouTube channel. Also, there will be 5 to 10 minute time after the presentation for questions and answers. Please post your questions on the Q&A section of the WebEx tool. Tonight, our speaker is Mr. Jim Duarte. Jim Duarte is a fellow of ASQ and is certified as a quality engineer, CQE, Six Sigma Black Belt, and Lean Six Sigma Master Black Belt. He will make his 3rd trip to China to keynote the China International Industrial Fair and will guest lecture at Galar University. In 2018, he was a guest lecturer at National Tsinghua University, Taiwan with Dr. Noriaki Kano. Recently, he has been asked to assist with ASQ's rollout of the Quality 4 initiative. His professional life includes corporate director of quality technology and strategic business analytics at 2 Fortune 100 companies. His current research is dedicated to data science, big data, advanced analytics, and Internet of Things, IoT. He has co-authored 7 patents for analytical methods in oil and gas and utilities, which include 2 in the US and 5 international patents with another still pending. Along with many years volunteering for ASQ section offices, he also served as chair of the Ishikawa Medal Committee and a member of ASQ's award board. Thank you so much, Jim, for accepting to be our speaker tonight. Now I would like to hand over to you. Please take it away.
Thank you very much, Dawn. Yes, this topic today started many years ago in my mind as I looked at the traditional ways that quality professionals look at data and analyze data. And for so many years, we've been using sampling in control charts and sampling in many other ways to see how we would use data to answer questions. And as I moved forward working for an analytics software company that had advanced analytics, I thought there are many opportunities for quality professionals to expand their capabilities by looking at data warehouses or data marts, databases. There's a lot of data that could be used by quality professionals in conjunction with other areas like engineering and especially with the IT and OT areas. And now that we're moving into artificial intelligence and many sensors being attached to processes and high-speed things, I think that the quality professional has an opportunity to work with engineering and work with IT and other areas and add a lot of information and a lot of expertise, because quality professionals know the most, in my book, know the most about processes and products and then how that interacts with the data that's available. So let's start talking about some of these things. If we look at the elements in the modern industry, there's things like Industry 4.0, smart manufacturing, manufacturing 4.0, and now recently ASQ has adopted an activity around quality 4.0. And being a member of that advisory board, I really want to see the quality professionals be able to be innovative and use more data to be able to answer more questions. And if we look at some of the things that are available, sensors, even wearable technology in the healthcare field, and we have many connected devices. And I started speaking about the dangers of connected devices in your home back in 2016 when I spoke at the Innovation Conference in San Diego. I brought out the fact that connected devices in your home really are not as secure as we would like them to be, and they do offer up some concerns that we need to look at in our personal lives with connected devices. There are actually refrigerators that have screens, and you can actually read your email on the screen of your refrigerator. And there are many things coming along that we need to understand. But when we get back to our quality profession, then we need to be able to quickly translate information into intelligent decision-making, and secure and trusted communications need to be part of what we do as quality professionals. So as we look at this, what is big data? Well, big data we've seen is velocity. If you see on the left, it's a high-speed packaging line. When we look at quality, we look at things as continuous or discrete processes. Well, there's an overlap there with discrete processes. As we see on the left, we're filling one bottle at a time, but the process is so fast that the data is being collected like a continuous stream, like a continuous process. So we have to now look at how would we handle this. If we look back at historically, taking a sample of size 5 every once in a while really wouldn't give us what we need to know about the process and its stability. So we need to be able to have the capability of looking at these high-speed processes and be able to take that data and analyze it as it streams. It's also true for healthcare people when you're looking at operating rooms and things like that, where there's streaming data coming in from different monitors that doctors are looking at during surgery, for example. There's also the volume of the data. Data volumes have significantly increased over the years, and we need to be able to see how we can use that volume of data to help us in looking at the strategies that run our processes, and then that volume of data that tells us about what's going on. Again, not every one of us is in an industry where we have data coming that fast, but for those who do, there are a lot of opportunities, because it's not only the volume of the data, but it's the volume of the production that we're trying to monitor. And then there's the variety of data. Data has many locations, many databases, many places, and the variety of locations as well as the variety of variables gives us the opportunity then to look at a whole lot more things. As we can see on the left, the tractor of a trucking company, they now have many connected instances of data that are brought into the organization to look at preventive maintenance and many other things. The other thing that this helps with is when you're looking at that data, for example, from a connected device like a car or a truck, it also not only gives you information about repair cycles and maintenance cycles, it also gives data for engineers to look at design for Six Sigma. When you start looking at future designs, you can take historical data and use that for looking at the future for your designs. So there's a lot of opportunities with big data. And the question that I was getting when I was teaching this class the last couple of years, early on in the first class, people said, well, who does what? Not in so many words, but that's what came out is, well, who is it that's responsible for getting the data? Who's responsible for storing it? Who's responsible for cleaning it? Who's responsible for analyzing it? Who's responsible for interpreting it? And who's responsible for then communicating that to management for decision making? All those questions were brought up in the early training classes that I was holding. And so I got with a friend of mine who's a computer geek. You'll see him in the Data Scientist 1 category in a few minutes. But then we started talking about how to answer all those questions for people. And there was an article that we published back in February in Forbes, which was called How to Create a Data Science Dream Team. And in that paper, we do the generic answer to those questions. And then I published just recently in the Software Quality Professionals Journal, one specific for quality professionals. So when we look at this, why do we even care about big data? Well, number one is, for years we've been looking at sampling and trying to draw inferences from samples of data sets. We now have the technology where we can look at literally the whole population from a set of data. And with that information, then we get rid of some of the probability issues of type 1 and type 2 error of, have I done something that would cause me to make an error on the positive side or an error on the negative side? And when I look at that, have I found false positives or false negatives? Well, the more data we have, the less the probability is that we're making an error in that kind of decision making. So then we look at real-time streaming of data that's continuous. In the oil and gas industry, streaming data. In beverage processing, streaming data from flows of liquids. We look at it from sensors that are in our artificial intelligence or our robotics area. And then when we start looking at why looking at big data, one of the big things that I've run across is in design of experiments, a DOE is only as good as the variables you put in it. If you don't have the right variables, you can optimize till the cows come home, but if you're optimizing on the wrong variables, then when we start looking later in this talk about machine learning and finding key variables, we can then refine and make sure our DOEs or our controlled studies are actually using the right variables for a controlled study. And then there's control charting. How many of us have dashboards that are huge with all kinds of control charts? And some of those are more important variables than others. Again, through machine learning and finding what the key variables there are, we can start prioritizing which control charts give us the most information about our process. So that's been a really big thing that I've been able to work with people on, is then looking at their dashboards and saying, okay, do we need to look at 50 control charts when 5 or 6 will do? Because those are the key variables that interact with our processes and our products. So then when we take advantage of advanced analytics, we can look at it from two perspectives. One is called unsupervised analysis. Unsupervised means we're not trying to predict anything. We're just looking at data patterns, like we start looking at cluster analysis or principal components or things like that, where we're just looking for data patterns. Unsupervised, we're not trying to predict anything. And then there's supervised analysis, where we're trying to predict something, and that's where we get into machine learning, and we're actually doing things like regressions and neural networks and decision trees, where we have a variable we're trying to predict. And then text analytics can go both ways. It is possible to actually put text into a machine learning model and try to predict an outcome. On the other hand, there's a lot of text analysis that's done that's just looking in an unsupervised way of what's going on. So who does all these things and who has what role in making sure all this is done in the right way and the most efficient manner of using our resources? So now, back in September of 17, I published this paper in Quality Progress, where people have pulled out two terms that I use here and have been talking to me about those the most, which is data at rest, which is data that's sitting in a database or a data warehouse or a data mart, and it's been collected and stored and sitting at rest. And it's used a lot for building models and training models and doing things like that. Then the second term is data in motion. That's where we have data coming in, streaming through systems and sensors, even click streams that we can look at for people who are buying things on the internet. So there's a lot of different ways to look at these things. A good friend of mine published the paper on Let's Get Digital, and Nicole Radziwill talks about the many ways of the fourth industrial revolution and reshaping it as how we think about quality. It's more than just data for engineers and manufacturing people or service people. It's also about the quality people. And then most recently, there's an article by Greg Watson, former president of ASQ, where he gets into the details of quality 4.0 and some of the things that are going on and have gone on for the last 20 years. Greg is a great resource for information like this. So those are 3 papers you may want to consider going back and looking at. So to summarize what Greg says, that the rapid advancements in technology have made some far-fetched fantasies of the past a reality. So when we thought about just having to sample to get information for control charts or other things, we now have the ability, like I said earlier, to do that on the fly. And those advancements are affecting quality professionals and the profession. And what methods are there out there that we can use, that we can adapt for the future of quality, and what does that mean for the future of quality? I've been involved with a lot of organizations where quality is kind of left behind. Even the software salespeople talk to IT or OT, OT being the people that are in the area of artificial intelligence and the areas of connected devices, while IT is on the administrative side of the computing. But what I've seen is even in the sales, quality gets left out, whereas, like I said earlier, they have the most knowledge about processes and products. So some things that I think I have found that management believes, and we need to change some of these beliefs. And my partner and I, Jared Dane with HP, he and I are trying to get in front of management with the article, like How to Build a Data Science Green Team, and talk to management about basically that everything that's data does not belong to IT or OT. Data belongs to the organization and has many places where it's applicable. Data scientists, they believe, are just IT or OT personnel, that if it's data, you throw it over the wall to the IT department and expect magic to come back. And then we've created analytics centers of excellence, and they will solve everything. Well, most of those people are not involved with the day-to-day operations. They're not part of the subject matter experts like quality and engineering and manufacturing. They also believe this ACE can be independent of processes and products, which we know if your analysis of data doesn't take it in context, it doesn't give you as much information. And that only the ACE, this Analytics Center of Excellence, can handle complex problems. And we'll see that when we look at the different roles of data scientists, that's not true. And then we don't need participation by process subject matter experts. So management has this belief system that actually is not productive for the organization for good decision making. Not all the people are put into a collaborative effort to do things that gives the most information from the most people about products and services and processes. What about quality? Well, I've come up with a terminology that I'm putting forth, and it's called IMAGILYTICS. It's a combination of imagination and analytics. And what my point is here is that we have, pardon me, we have very good analytics people, and we have very good creative people. What I'm suggesting is that we put those together. So for example, if you're in a quality department and you know how to monitor stability with a control chart, how could you use your imagination to help put that control chart into another area? For example, in sales and marketing, every sale that a salesperson tries to make and fails, that's like rejecting, having a product rejected. It's a failure. So what if we were to help sales and marketing look at trends and processes and the stability of the sales process? So I'm not saying we all go running out and start sticking our nose in other people's business, but what I would have you think about is people think of quality people as inspectors or certain kinds of activities. We need to broaden our application of our talents and our capabilities throughout the organization. And quality isn't just inspecting and writing manuals and doing things like that. It's much more. So I hope you can see where I'm going with Imagilytics and using your imagination. Imagination is really valuable when you're doing design experiments. So rethinking how to handle data. Like I said earlier, so many times management just throws the requirements over the wall to IT or OT and expects magic to come back. When in fact, if we look at the right-hand side, making good decisions really should have a collaborative effort from many people in the organization and many departments in the organization. So where are all these data scientists that we're talking about? What are their roles and where do they live? So when we start looking at this, we'll take a quick look through here. The data scientist one is basically the computer geek, for lack of a better term. So they're a technical expert, and they are the ones who arrange for storage of the data. So we're talking about data at rest. They're the ones who would create the data warehouses, databases, the different places where data can be stored. And then they should be responsible for cleansing it and formatting it so it can be analyzed. And the number 3 bullet, giving users access. As I've been to conferences over the last few years, one of the biggest gripes that I hear from quality people at quality conferences is, yeah, we have all this data, but we can't get access to it. Nobody will let us in. And that's something that I think that collaborative effort that I suggested in the previous slide is where we would look to be able to see who should have access to what. So one of the things we look at here is in the formatting of the data, another piece that becomes difficult in the formatting is if the data is in a variety of locations. So if we have some data over at Oracle in the database or something over in Teradata in a data warehouse, and we've got a bunch of stuff it's sitting in Excel spreadsheets on people's desks, how can we bring that together? And the IT department or the data scientist one kind of people should be able to help us to bring the right data together for the analytics. So it should be clean and it should be organized and access available for people to do their analytics. And this is a very important part for the data scientist one. They're not usually in the quality department. I wouldn't expect a quality professional to be able to do all of the things a data scientist one does. But what is the responsibility of someone in the quality department? They should know enough to carry on a conversation about data and its cleanliness. Being cleansed, what are the issues you're finding in the data that can help the data scientist one better cleanse it? What is it about the formatting of the data? So the quality professional should know enough about the databases, data warehouses in general to be able to be conversant with the data scientist one. And that's what my partner in co-author, Jared, is looking at, is how do we integrate that and get those people to be more collaborative with the rest of the organization. Then we look at a data scientist two. And the data scientist two then has some technical expertise, but they're more about looking at the technical aspects. So the technical aspects of data analysis is where you get into things like machine learning and different aspects of advanced analytics. So when we're looking at advanced analytics, then we have a data scientist too who looks at that and actually gives us the ability to do those things. So a data scientist too would be someone who knows things about machine learning, neural networks, different kinds of modeling tools and techniques, different ways of looking at unsupervised data, looking at cluster analysis, or looking at principal components or ways to describe the data. So the data scientist too then is really familiar with technology, familiar with advanced analytics, and basically can help the organization looking at complex kinds of things that are in the organization. So then we have these two people here working together on the technical aspect and then setting up the data for advanced analytics. The data scientist 3 is sometimes called the citizen data scientist or business analyst. They are really good with business intelligence software like Tableau and Spotfire and software like that, where they can look at data patterns and see what's going on and look for trends. And they're the ones who then are really good at then digging into and looking at data from that perspective. The part that they lack in the data scientist 3 that's available from the data scientist 2 is the data scientist 2 in building models can get a better look at interactions. And we'll talk about this in a few minutes about how we look at interactions, whereas in business intelligence, it's difficult to look at third and fourth order interactions or things like that with just BI software. And the data scientist 3, the data scientist 3, then can use pre-programmed models created by the data scientist 2. So the data scientist 2 builds a predictive model that's going to be used continually through time. The data scientist 3 can be trained on how to enter data into that software and adjust it for time and adjust it for process changes, but able to use a pre-programmed model. And then they would create reports that would be coming out for decision making. So they would do the repetitive kinds of analytics like we've done historically, the repetitive analytics like we've done with control charts and things like that. That would be your data scientist 3. And then your data scientist 4 is the gatekeeper, the storyteller, who actually then takes this information, ensures that the reports are accurate, and gets that communication out to the different areas. So they can do supplemental analysis to answer senior management's questions. So for example, the data scientist 4, the storyteller is telling a story to management of what they found in the data, and senior management has a question. Well, the data scientist 4 should have enough wherewithal to be able to do some BI or analytics on the less technical side to be able to answer senior management's questions. So on the top of this slide, you see it's food for thought about who does what. Now, I don't know of any individual it's rare to have an individual that can do all 4 of these jobs. So that's something that Jared and I have considered as we've gone through this work, is then finding the right people and getting the right communication and collaboration set up so that we have people that we know are doing the kind of job that they have for their strengths and looking at those kinds of things. So now what does that look like in a diagram? So the data scientist 1 builds the data strategy, cleanses the data, stores it, formats it. They work with the data scientist 2 to validate the strategy, identify and collect the data. The data scientist 2 then takes it and does a validation through modeling and unsupervised analysis in some cases. Pardon me. And then develops analytics, builds models, and is a partner in this SME collaboration. The data scientist 3 does a lot of data rummaging using business intelligence or BI software. They can rummage through data and look for patterns, see what's going on. They can apply the analytics that they receive from the DS2 and use that by plugging data into predictive models, for example. And then the analytics results, they can help interpret that in context of processes and products. And then they're a subject matter communicator. So they start looking at this interaction of these people. Then they have an overlap with the DS4 to validate reports and interpret reports so that the storyteller, the DS4 then, is giving the truth and the correct information to management. And they're the analytics gatekeeper to make sure the right information gets to management. They manage the liaison across the collaborative group of subject matter experts, and they're an organizational communicator. And we notice all 4 overlap in the center, that they have to have access to the right data when they need it. So having access to the right data is really important. So now then, how does this collaboration work? So we have engineering and people in the process that help create and collect the data. So they understand process details, the machines, the materials, and the operating parameters. Then we have IT and OT. They store it, cleanse it, format it, give access. And they're working with information that's from robotics, sensors, software, artificial intelligence, and data structures. When we talk about connected devices, things that are communicating, for example, some of you on your homes may have a smart meter, electrical meter, and that's a connected device that communicates to the utility company, and they can actually give you feedback on the best time to use certain of your devices in your home to help optimize your usage of electricity and possibly bring your bill down. And then the data users. Those are the ones who analyze and use good data for advanced analytics. And so the users are 2s, 3s, and 4s, and Lean Six Sigma folks. So I give you two diagrams here of ways to look at the collaboration effort. And then we know that the data users know the specs, expectations, functionality, and performance. They're really good with information from customers. And when you put it all together, that's how you get good decisions in an organization. So when we look at all this, where does quality fit into this activity? So the data scientist one, if you're a quality professional, how do you fit in? Learn the lingo, learn some of the terminology so that you can communicate with what data you need, where you need it, how it needs to be cleansed, etc. But respect what I call the IT union. My father was a Teamster, and I can remember him coming home evenings and being frustrated. He said, you know, if I saw a pile of dog poop sitting somewhere and there was a shovel, I couldn't pick it up because I'm not in the shovelers union. And this was back in the 50s when unions were really, really strict about who did what. Well, the IT kind of has this union mentality of data's theirs, and they're the ones that handle it and control it and give access and all those things. So you need to respect that as you start working with them, start breaking down those barriers. Make friends. Be friends with the IT people and use the relationship to be able to get access to more and better data. What do we do with the data scientists too? From a quality perspective, analytical geeks are important, and we'll show some examples of that. I'm one of those, and I've been in quality. I've been a member of ASQ for over 40 years, but I've always been an analytics geek in all of the quality work that I've done. I've solved a lot of problems with advanced analytics, and I've solved a lot of problems with simple control charts. So it's just a matter of knowing what your strengths are. Get some training in advanced analytics. At least, again, learn the lingo. You know, neural networks, I'm sorry, I can't explain to you how they work very well, but knowing what it does and knowing its applicability is important. And use your imagination to make your mark. How can you help other people? You know about processes, you know about products. So if you're working with a data scientist too, who's a real analytics expert but doesn't understand the products and processes, use your imagination to give examples to help that person to give you the best answers to your questions. And that citizen data scientist or business analyst, these are quality practitioners that are using the data to improve products and processes. So when you start looking at things like Six Sigma, I've put some things together on how we would take Six Sigma and in DMAIC, in the measure phase, how would we use big data? Well, in the measure phase, business intelligence software, BI software would look very well in that area of the measure phase, where we're looking at patterns and rummaging through data. Then use your imagination, again, to make your mark. So as a data scientist 3, where you're using the data to make decisions on the shop floor, as it were, or in offices, then use your imagination to promote the training and the tools that you have and how they can be beneficial to other people. The data scientist 4, Interact with other subject matter experts for making good decisions. So interact with your buddies in engineering, in sales and marketing, in various areas. Then when you start looking at decision making, look at it from the broad perspective of the enterprise. And then the data scientists, for when you're working with them, help them understand what good data is and the methods that are used to spread the truth about the analysis and what's going on with products and processes. So these are the important aspects that we would look at when we start looking at the different aspects of data science, and then how can we as quality professionals help advance that and be part of that activity. So now that comes to creating data. I look at creating data for one of my favorite data scientists, Mark Twain. And I've checked this out, and he actually said this. But if we think about it, collecting data is a lot like collecting garbage. We got to know what we're going to do with it before we collect it. What this does is, if you look at what Mark Twain is saying here, it helps you avoid data hoarding. And so many companies I ran into when I was working with a software sales organization, so many organizations that we went into and we talked to were just hoarding data. They were hoarding data in databases. Somebody would create a data warehouse, but they were just hoarding the data. They weren't doing anything with it or anything major. So we need to really look and think about where we put it. What this also helps us with is data variety. So if we know what we're going to do with it before we collect it, we can make sure that it's formatted and put in a place where it can be joined together or put together for the best way to analyze data. So Mark Twain wasn't really very far off back in the day when he said this, as we think about it more. So we need to actually build a communication system, and we can help do this as quality professionals about where will we store it? Who needs access? And when we start looking at Lean Six Sigma, we've done so much work on sampling and collecting data during Kaizen events, and it's very limited. Whereas if we look at DMAIC from the perspective of how can we benefit from big data, especially in the measure phase when we're looking for patterns and what's going on, and then in the analyze phase, how can we use advanced analytics, we have the capability then to say, okay, who really needs access to the data and why do they need it? And where is it? Can they get to it? So, and then how will you analyze the data? When I went into my graduate studies in statistics, one of the first things when I got into the graduate program, one of the first classes the professor said to us, okay, you've got your bachelor's degree, you know how to analyze data. He said, but you need to analyze it before you collect it. And we students looked at each other and said, what does he mean, analyze it before you collect it? And then as we went through graduate school and we got into more detailed analytics, it was like, yeah. In academia, what happens a lot is students are given a data set to practice things that they've learned. Model building, we were taught how to run linear models, how to do all kinds of things in grad school, but the data was already prepared for us. Well, when you get into industry, that's not true. In industry, when you're going to solve a problem, you may not have the data already formatted and in your lap like you do in school. You have to go out and you have to collect it, you have to format it and all those things. And that's what this professor was telling us, because he'd worked in industry and he said, you've got to analyze it before you collect it. What inferences are you trying to make with your data? And if you know what inferences you're trying to make, then how would you collect it? If you're trying to do a regression or you're trying to do cluster analysis, how would you then collect the data to meet those analytical needs? And it really opened our eyes, and we had a really good graduate school in statistics that was very applied. So then, are you going to use machine learning? Is there text available? Now, text analytics really, when we talk about it, we can talk about it from two perspectives. bottom up and top down. Bottom up is, okay, I have a document, but I have no idea what's in it. So for example, let's take all the reviews that are written on the internet about a product or a restaurant or something, and we have all of this data that we've collected from reviews. We have no idea what the patterns are in what people are saying. That's bottom up. So the first thing we do is we start looking at what's in the data to see what are the patterns of the text. What's it telling us? And when we look at that, then once we get the patterns and we look at what's going on and we want to fix something that we find is a pattern that our customers are talking about, then we can go top down, which says, okay, I need to look for these topics. And I need to see where I can find information on these topics that our customers say are important. And that's top down. That's called content categorization. So bottom up, we're looking at finding patterns in the text. Top down, we're now looking at categorizing content that we found from what we got out of our bottom-up analytics. So now then, what are we going to do with the data? What decisions do we need to make? So the business analyst, what does the C-suite need? What does the director of purchasing need? What does the vice president of HR need? What does the vice president of quality need? So we start looking at the interaction of the members of the C-suite. What do they need? And what decisions do we need to make? And so what are we going to do with the data to make sure we can answer those questions? And then process improvement, things like Lean Six Sigma, and creating significant savings and efficiencies. So these are the things we need to ask ourselves about what we're going to do with the data, which helps in the collection and the storing and the cleansing and the formatting. All those things we said we want the DS1 to do, the Data Scientist 1, this helps define that so that we can collaborate and get that information that's better for us to move forward. So, in my opinion, it needs to be properly cleansed, stored, formatted, and accessible to make better and more consistent decisions, not just hoarding it. Accessing data. To me, a database is like a landfill. Everything goes in it. A data warehouse is an organized landfill where we start organizing things into categories. A data mart or data lake is like a recycling center. We're going to do some specific things with what we've found. And then an Excel spreadsheet, to me, can be just like a compost pile. Anything can go in there, and we just wait for it for lack of a better term, we wait for the data to ferment. My favorite slide for data access. If you can't get to it, you can't analyze it. Now I'm going to insult your intelligence here for a minute. These are things you already know and you know about. So if you put yourself together a way to look at your customers, what they receive, the process measures and product measures, we do this all the time. But now, the next thing to look at is if we have that information, the final column is the one that I want to emphasize. Do we have access? Where is it? What's the source for that data? And do we have access? So when we look at that previous spreadsheet, as it were, that we do all the time about what we're measuring for our customers, what we're measuring in our processes, we've done that for years. But what I'd have you think about is, now, where's that data sitting if it's data at rest, and do you have access to it? Can you actually use it in a meaningful way? Same thing with product measures. So process measures, product measures, where are the data sourced, where are they stored, and are they accessible? So now machine learning. Quickly through here, give you a brief look at, as we said before, supervised, unsupervised analysis. We get a model built. We can throw some new data in it and do some predicting. And then we can get a predictive model, or on top, on the far right, unsupervised data where we get things grouped together. And then we can annotate data so we can look at that. So one of the things that we would look at is, can we actually take this information, build it into a predictive model for analytics at the edge? I'm going to show you an example in a minute of analytics at the edge that will relate to almost everyone on the call. So when analyzing data, I'm proposing 7 newer tools that we would look at, from text analytics to predictive modeling, clustering. Network diagrams, to me, will take the place of Pareto's. Sorry, Dr. Duran, but one network diagram can do what 3 Pareto's can do. Discrete event simulation, event stream processing, which is basically a control chart on steroids, looking at data that's coming in at high volume, high velocity, and then vision systems that actually can look at things and categorize them. And the vision systems looking at some of the very important things in looking at vision systems, like facial recognition, label recognition. Is your label on correctly on a product coming off of a packaging line? Different kinds of things. Vision systems looking at healthcare aspects. So text analytics, these are several things that we can look at, all the way from voice of the customer down to health and safety logs. Again, I used my IMAGILYTICS slide there to get you to think about how could you help the HS&E folks analyze their data. Word clouds. The good news is we can find out what's in a document with a word cloud. The bad news is it's only a frequency count. There's no context there. So when you start looking at this, we don't know if button, for example, there, is that the button of a shirt or blouse, or is that the button on a keyboard, or is that a button on a machine? We don't know. All we know is that the word button came up a lot of times. So it's just frequency counts. It's not in context. So now, look at accident reports. Look at this. Wow. It looks like people keep injuring their left finger in a mold. Well, again, these are not in context. So if we start looking at them in context, then we need to look at it from a different perspective. So to keep moving here, predictive models. I used the word analytics at the edge a few minutes ago, which is the far right here. The example I'd like to give you to think about is the far left, data at rest. Data on how automobile engines consume gasoline. Models were built after carburetors went away, for those of you who remember what a carburetor is, and we got electronic fuel injection. Well, electronic fuel injection has to be regulated very precisely. So models were built on how to best utilize fuel and optimize an engine with electronic fuel injection. Then data in motion was used from test engines to test the model until it was refined, and the model was refined using data in motion, and then that data in motion is also what is collected in your car while you're driving down the road. Data is being collected on your speed, your RPMs, etc. And then analytics at the edge is that's burned into a chip, and that predictive model now sits under your hood, and that's analytics at the edge. It's analyzing your driving patterns. You push on the gas, you change something, you shift gears. That predictive model that's in that chip under your hood then adjusts the flow of the fuel to your engine. So this is what I found to be the easiest way to understand predictive models, how they were created from data at rest in databases, how they were tested with data in motion, and how they actually operate using data in motion. And then they are programmed in a chip that goes under your hood, and that chip then holds a model that predicts how to best proportion the fuel in your fuel injection system. So you create the model, you use the model, and you deploy the model. Quickly, we're going to go through here. Some of you may have seen this in previous talks that I've given. You've got coating peeling on a pan. First thing, when I've taught this in class, I asked people, what's the first thing you do? They would start brainstorming the coating process. We've got to figure out why the coating is peeling. So we look at the coating process. The pan is stamped out of a piece of aluminum plate, upper left. so you've got these pans hanging. They're dipped into a bath of acid and electricity and certain temperature, and you get a pan coming out that's been coated. So now a DOE was run. We looked at certain variables. So we looked at the acid concentration, soak time, etc. So we did a DOE focusing on the coating process. Well, interestingly enough, to get that pan, you have to roll aluminum into a plate to a certain thickness to be able to stamp it out into a pan. So the upper picture shows the rolling of that plate to get it down to the right thickness so that we can make pans out of it. So we didn't get a very good response with our DOE on improving the coating. So what we did was say, well, let's look at all the variables end to end and do a machine learning model. Let's take all the variables all the way up from the rolling process all the way through to the coating process. And what we found was the number 2 variable was the particle size of that white emulsion that you saw in that rolling process, because come to find out, engineers told us we were nuts when we started. Come to find out, the particle size in that emulsion is what conditions the surface of the metal to accept the coating. So the strength of the metal and its conditioned surface, the 2 strongest variables for having the coating not peel off. So this is where, like I said earlier in a DOE, if you don't have the right variables, you're not going to improve the process. So that's why I advocate doing machine learning where you can, to look at all the variables, find out what's important, and then move forward. So then what we found out, particle size, that white liquid that bathes the rolls as a coolant and lubricant is what was actually conditioning the surface of the metal to hold on to the coating. So then we look at the key variables. What was the second thing I talked about? Control charts. Would you need to do control charts on all of these variables, or would you need to focus on control charts that are more in the way of giving you information on the performance of the process, and which would you look at more? Bottom left there, it's a negotiating point with IT folks too, that you don't need as much data as you thought you did. So they're happy if they don't have to download as much data for you. You just negotiate with them to download all of it once a year or every 6 months to make sure this Pareto hasn't changed. But then you don't have to utilize as much storage or processing time, and that makes the IT folks happy. So design of experiments, make sure we have the right variables, and the control charts, process monitoring. Decision trees, the key here is that when you start looking at decision trees and you find an optimal leaf on the tree, it can show you interactions. It has and logic. This is true, and this is true, and this is true. So that as you move down so that as you move down and pick up 1 variable, 2 variables, 3 variables, that as you look at picking up more variables and you find this is the optimum, then what you've got is that's an interaction. And the question I've asked people and gotten the same answer every time is, have you ever had a problem arise and no alerts went off? And 100% of the time the answer is, yeah, that's happened. We've had a problem, but we didn't have any alerts go off. That's because alerts are set up on OR logic. This variable is out, or this variable is out, or this variable is out. Whereas decision trees use AND logic, where this variable is at this level, and this variable is at this level, and. Very valuable tool. Network diagrams. How network diagrams work is you can take a whole bunch of variables, and when we've done Paretos, we've talked about time and cost. You can put all that in one network diagram. So for this one, for example, we can see that the biggest problem for automobile warranty in this database, that the biggest one was passenger cars, pickup trucks, 8-cylinder engines. We've got claims, and we've got frequency in dollars. We've got labor costs. We've got information on turbos. So we've got all this information in one diagram. So we have dollar data, we have frequency data, and then when we break that down to the next level, we see there's 4-cylinder and 8-cylinder engines that are big culprits. The 2008 model year in this particular data set was a biggie, and it was 4-cylinder engines have the biggest material and labor costs in these cars. So the 2008 4-cylinders were the ones that biggest problem. 2009, looks like we got things fixed in the next model year, helped out. Look at 2006, it's tiny. So what did we change between 2006 and 2008 that gave us a lot of warranty costs? So event stream processing, we're not going to go through this in a lot of detail. We need to get down toward the end. Event stream processing, basically you can look at this at your leisure, what it is and what it is not. The is not is focused at a at a particular software company that does it all wrong, and you need to be aware of how this works and don't get taken in by some software companies that don't know what they're doing looking at event stream processing. Again, if you know it, what I've added here is the third column, analytics. So when you're going to look at your process problems and how they're measured, what analytics do you want to do? What data do you need to do with analytics? Where is it? And do you have access? So another form for you to think about looking at in your processes, the same thing with product problems. And in my opinion, again, you possess more knowledge around analytical tools and have more expertise on products and processes than most of the organization, and you need to be involved in more things. Some examples of software packages that are out there, things that you can look at, both open source and closed source, give you an idea of all the ones that are sitting out there. And then you can look at this at your leisure. It's basically, if you're going to evaluate software, get involved, and what are some of the questions that you would ask? Make sure the software is not overkill, you're not spending more money than you need to, that it's not overcomplicated, so you're not buying more than you need, you're not buying something that somebody else needs to figure out how to install and configure. It's got to be simple for your IT people, or they're not going to buy it, or they're not going to let you use it. And then make sure there's no extra charges for installation and configuration and things like that. So on that note, we'll open the floor to questions.
Thank you very much, Jim, again for your presentation. You can post your questions on the Q&A section of the WebEx too. So one question is that what training opportunities for advanced analytics do you recommend?
For advanced analytics, there are a lot of universities that are offering degrees in analytics, master's degrees in analytics. So you'll see advertising from various educational institutions. I'm working with ASQ trying to put some training together for the Quality 4.0, and hopefully we'll get that put together and have that available in the near future also through ASQ.
Thank you, Jim. There was also another question about will the presentation will be available after the webinar? So I'm not. So
yes,
there is an.
Yeah, the recording.
Yes, yes. So the webinar is recorded and is available on ASQ Innovation Division YouTube channel. There is another question that has been posted: how to collect data when the processes are heavily done by hand?
That goes back to traditional. That goes back to your traditional quality control, where you have manual data entry and data collection. That's just part of the issue with manual systems is collecting the data manually. There are systems that can do it automatically depending on what it is. I know if it's measurements on devices and things, for decades there's been a company called Datamite that has collected data and uploaded it. It's a manual method, but with a technology aspect to it. And that's one that I can think of off the top of my head.
Thank you. Another question is that where does data analytics fit naturally in an organizational structure? Do you see any trends reorganizing structure and data analytics?
Yeah, one of the trends we're seeing is that ACE I talked about, the Analytics Center of Excellence. I like it up to a point, except that it's usually under IT, and the people are really good at analytics, but they don't understand the processes and products. So there needs to be an examination of that, and it shouldn't be just totally independent. There needs to be integration with the subject matter experts, and there should be some either heavy communication from the subject matter experts like engineering and quality with that organization, or those people who are analytic experts, the DS2s and DS3s can actually be in the organization like engineering and quality and things like that. So it's kind of an interesting dilemma we have now, that if we leave them totally independent and part of IT, they don't really learn the systems and processes. Whereas if they're in the functional areas, they have the systems and processes, and then they learn the analytics. So it's kind of like which is better, being an analytics expert who knows the processes, or be an analytics expert who can just help with problems from the organization.
Thank you. We still have a few minutes, so you can post your questions if you would like to on the Q&A section of the WebEx tool. And I should remind that you can find the recording of this webinar on ASQ Innovation Division YouTube channel. So another question that has been posted, companies are not moving to a quality 4 fast enough. What's your comments or suggestions?
Well, the suggestion we're taking through ASQ is that ASQ needs to start marketing or communicating Quality 4.0 to management. We're looking at a two-pronged approach to communicate to management and then create training. From the question earlier, create training for the individuals or users. The Quality 4.0 survey that went out earlier this year, several of us are very, very disappointed with that. They went out and asked senior managers about Quality 4.0, and the senior managers didn't know what it was or anything about it, and the information that came back was really not very useful. So we're working with the Quality 4.0 organization at ASQ to try to get that information to management and actually show them something similar to the slide that I showed you of throwing it over the wall to IT versus having a collaborative group and how that can work. So ASQ is being nudged very strongly by the membership to actually get that education out in front of management. We're really hoping to do that because management doesn't know what it is, and they don't see the integration of Quality 4.0 with Manufacturing 4.0, Industry 4.0, or Smart Manufacturing. They don't see that yet, and they need to be educated. And I'm as frustrated as probably the person who asked the question about that.
Thank you. And I think there's another question related to that one. What should I do when my company does not know what to measure customer, not provider specifications?
I'm chuckling because that's a position we've all been in, and I'm going to give you a little advice here. My cousin is retired U.S. Army, and he told me something that I think is very true. It's dangerous to be right when the people in control are wrong. So when you start looking at how to help people learn what to measure, a lot of times that comes out of solving a problem, either in a Kaizen event, Lean Six Sigma project, something that comes out of customer service, complaints or defects. Sometimes a negative can be used for a positive if you can solve the problem and show why that needs to be measured going forward from two perspectives: the end measurement, failure, not failure, and then if you can find the variables like I showed you with the machine learning, if you can find the variables that are related and show how important it is to control chart those or have those as key predictor measures, oftentimes by solving a problem and showing how you solved it and what you did and what you would suggest moving forward can do a lot. I did that early in my career. I solved a problem when engineers and people told us we were nuts. You statisticians go away, don't bother us. What you've come up with is totally irrational. But when we found out that it was truly the variable that needed to be measured and the ancillary variables around it, when we finally proved that, we finally got acceptance. And when we did, we got the right measurement system in place for that. And that company that I worked for, we actually took the market on that product for the next 10 years because we were head and shoulders above the competition after we were measuring the right thing. So sometimes you can take a negative and turn it into a positive.
Thank you. And I think this is the last question. Is there any document, book, or material you can recommend to start learning on this topic, quality and data analytics?
Read the articles that I showed you, and we will be putting out more articles. But most of the data science information that's out there is pretty much computer-oriented and pretty complex. Dan Jacob has some good stuff out there, but he's more of a computer guy. So look up Dan Jacob's stuff, Nicole Razawil, again, like I had here, Greg Watson, my stuff that we're going to be putting out some more. Jared Damon are going to be putting out some more things. And then Jared and I are working on a book, but I don't know one out there that actually talks about data science in a way that breaks it down into these 4 pieces. Some people are throwing out the term data engineer, and to me it just muddies the water when you start trying to put more titles and communication around different terminologies. So that's all I can say for right now is that, yeah, we're working on it.
Thank you so much, Jim, again for your presentation and speaking to us tonight. And I would like to conclude this webinar event. And thank you all again for joining this webinar, and have a very good night.